This is mathheals.com, where you can find more links to YouTube videos, computer science and math. Let's take a look at logarithmic functions. And the first thing we'll talk about is our definition of log. Specifically, the log form versus the exponential form. Now we have log, and this b here is usually a number, and it's smaller and it's kind of set down. That's our base. So the b is our base. And we got, that's our log form, and we got an exponential form. That's b to the p is equal to q. So if you got it in log form, want to rewrite an exponential form, you take your base to a power the other side equals what follows your log. If you want to go this way, then you just reverse it. Now we got some special bases. If you just have log, and there is no number that's small and kind of set down, there your base is 10. And if you have this ln of x, that's natural log of x, here your base is e. E is 2.7, a bunch of decimal places. This first one is called our common log, and the second one is called our natural log. I'll refer to it as ln a lot, just to shorten instead of saying natural log over and over. Okay, let's look at our first problem here. It says write the log equation as the exponential equation or vice versa. So we're starting with the natural log of 7 is equal to 1.9459 ... Now, natural log, ln, down here, it says base is e. So we don't have a number there, but if I were to put it there, technically it's incorrect, but I'll temporarily put it there just to emphasize it. That would be our base. And our formula says we'll take our base to a power of the other side. So we got e to the 1.9459 ... power equals what follows our log, which is a 7. And that's our answer. Our second problem, we got e to the third is equal to 20.0855 ... This is an exponential form. We want to go backwards and put it in this form. Well, this would be our b, if I were to actually label them. And this is our p, and this is our q. I could have done the same thing on this one. So our log form, right up here, says we're going to have log base is e of q, which is 20.0855 ... equals p, which is 3. Now, log base e is just natural log. So we got natural log of 20.0855 ... is equal to 3. These next ones are graphing. So let's take a look at this. Got f of x is equal to natural log of x minus 2. Well, I'm going to press my y equals. I press my clear. Now, we got natural log of x minus 2. I got a ln button. It's right here. Now, the log button right here is base 10. So this is base, that's base 10, this is base e. And then x minus 2. And you don't have to put a closing parentheses if you don't want. And then do a graph. Now, the graph it'll show you will always be wrong. Looks like it just stops, doesn't it? It doesn't. It keeps going forever down. It just gets so close that it just skims it. And the calculator gets confused and doesn't draw it. So I don't know why. But that's our answer right there. Look at another graphing one. We got f of x is equal to 3 minus natural log of x plus 1. Well, press my y equals, press clear. I got 3 minus natural log of x plus 1. And you can put a closing parentheses at the very end if you want, it doesn't care. And then press graph. These graphs are very deceiving. Looks like it just stops. Doesn't. Keeps going up forever. It just got so close to skimming that. Skimming it, never touching it, never crossing it. That's the definition of an asymptote, isn't it? Like this one. To find where it's going to asymptote as, you set this equal to 0. And this is got 1 at x equals 2. This one has got 1 at x equals negative 1. Anyway, those are our graphs. Now these next two problems, I'm going to work the problem first and I'll write the formula up. It's a very simple idea. The formula will make it look kind of complex though. So we've got natural log of e to the 3x plus 5. Now if I were to put a base on this, this is natural log ln, this is base e. Well, if your base here matches what follows it, like this is e and this is e, then the log and the e is going to cancel and just leave you the exponent. So you have 3x plus 5 as your answer. The formula for that says you have your log and your b is your base, and then b to the p power, that's going to equal to p. Basically, when we're working with natural log and e, they just cancel each other out. So ln of e always just cancels away. Now, this you may be looking at this one, by the way, and this says ln, this says log, and you're saying, whoa, that doesn't make any sense. If you remember from college algebra, natural log is just a special case of the log, where base is e. So it fits all the same formulas as all the other log problems. Again, I'm going to work this one, and then I'll write the formula up. We got e to the natural log of 4x. Now, if I were to put a base on this natural log here would be base e. Again, if these numbers match, these e's right here, and then the log and the e is going to cancel and just leave you 4x. So that'd be our answer. And our formula for that says you have b to log base b of q, that's going to equal to q. So again, if these match, then log and the b is going to cancel and just leave you what follows the log. Let me save this. This is logarithmic functions. There we go. Let's look at some more properties. These are our three main log properties. First one says you have log of something plus log of something. Well, addition becomes multiplication. So we got log of m times n. Now m and n can represent anything as long as they're not negative numbers or zeros. And if you have log of something minus log of something, well, subtraction becomes division. So that's m over n. And if you got a power, Well, if you got a number out in front of your log, it becomes power, I should say. Like that. So those are our three main ones. In some cases, it's beneficial for us to split it up into separate logs. In some cases, it's beneficial to put it into a single log. When you're solving a log equation, that's where it's beneficial to put it into a single log. If you're using some of our derivative of a log, then it's best to split them apart. Now these have LOGs on them, but it applies to ln equally. So let's look at our first one here. Got natural log of x squared y to the third over z to the eighth. And it says, use properties of logs to rewrite the expression as a sum, difference, or multiple of logs. We want to split it into separate logs. We have to look at the main thing that's happening in the problem. Like the main thing happening here is division. We got something up on top divided by something on the bottom. Well, division from property 2 becomes subtraction. So we got natural log of x squared y to the third minus natural log of z to the eighth. Main thing happening in our first parentheses here is multiplication. We got x squared times y to the third. Multiplication becomes addition. So we got natural log of x squared plus natural log of y to the third minus natural log of z to the eighth. Now we'd like to get the variables by themselves, like log of something, log of x, log of y, log z, ln in this case. And our power, property 3, we can put out in front of the log. So this becomes 2 natural log of x plus 3 natural log of y minus 8 natural log of z. And that's our answer. This one, we got the fourth root of x squared over x minus 3. Well, we don't like radicals when working with logs, so let's get rid of that radical. So we're going to rewrite this as x squared over x minus 3, all of it to the 1/4 power. Remember, whatever number is in this little slot right here, that's called your index, that goes in your denominator, and then you put 1 up on top. Well, now the main thing is happening. We got division, multiplication, but the main thing that's happening is we're taking everything to the 1/4 power. So I can take that 1/4 and put it out in front. So we got 1/4 natural log of x squared over x minus 3. Now as we rewrite the log from here on out, we have to keep the 1/4 out in front of all of our logs. Now the main thing happening inside the parentheses is division. Well, division becomes subtraction. So we got 1/4 ln of x squared minus 1/4 ln of x minus 3. Well, looking at my first log here, I got a second power, so I can put that out in front. So we got 2/4 natural log of x minus 1/4 natural log of x minus 3. I'd like to get the x by itself, but I don't have any property that allows me to split this up. We have a subtraction, but that says if you have log of something minus log of something, you have two logs, not log of log and then something minus something. So the last thing is 2/4 reduces to 1/2. So we've got 1/2 natural log of x minus 1/4 natural log of x minus 3. Let's see, number 9. Got natural log of 4x times x minus 5 over x plus 1 to the third power. Same instructions. Well, main thing happening here is division. We got something nasty on top divided by something nasty on the bottom. Well, division becomes subtraction. So we got natural log of 4x x minus 5 minus natural log of x plus 1 x plus 1 to the third power. Main thing happening in my first brackets is multiplication. We got 4 times x minus 5. Since all three of those are multiplication, we'll rewrite those as addition. So we got natural log of 4 plus natural log of x plus natural log of x minus 5 And the second part here, we got a power, so we can put the number out in front of the log. So we got minus 3 natural log of x plus 1. And that's our answer. We can't break that down any further. Now these next problems are going to have us go the other way. We're going to start out with multiple logs, and then we're going to work at getting a single log. Let's see. Natural log of 5x minus 1 minus natural log of 7x plus 8. Now in order to use these two properties up above, multiplication and division, addition and subtraction, the logs have to be by themselves. You can't have any numbers in front of them. So like if I had a 5 log of something plus 2 log of something, you can't use these properties. So get rid of any numbers before your logs before you begin. Well, if I look at this problem, there is no numbers in front of my logs. I just got log here, no number, log here, no number. So we can apply those formulas. Subtraction becomes division. So this gives us natural log of 5x minus 1 over 7x plus 8. Okay. Let's look at this one. Got 5 natural log of x plus 3 minus 2 natural log of 3x plus 4 natural log of x minus 7. Now we can't use the addition and subtraction while there's numbers in front of our logs. So first thing we have to do is apply those powers. So this one becomes natural log of x plus 3 to the 5th minus natural log of 3x to the 2nd power plus natural log of x minus 7 to the 4th. So now all of them, there's no numbers in front of them, so I can just apply our properties. Here we got log of something minus log of something. Subtraction becomes division. So we got natural log of x plus 3 to the 5th power all over 3x squared. And I'll bring down my last log. Now I got log of something plus log of something. Well, addition becomes multiplication. So this becomes natural log of x plus 3 to the 5th times x minus 7 to the 4th over, and I can apply that 2nd power through, and this would become 9x squared. Let's look at one more of those. So we've got 1/3 2 natural log of x minus 1 plus natural log of x minus 7 minus 3 natural log of x plus 8. Now, my dear Aunt Sally, order of operations tells me to do what's inside the brackets first. Inside the brackets, I got log of something plus log of something, but there's a number in front of one of the logs, so I need to apply that power first. So that becomes natural log of x minus 1 squared plus natural log of x minus 7. Now I know eventually I'm going to have to apply this power, so I might as well go ahead and do it now. So this becomes natural log of x plus 8 to the 3rd power. Still doing what's inside the brackets. We got log of something plus log of something. Addition becomes multiplication. So we're going to have x minus 1 squared times x minus 7. Well, before I can merge these two together, I had to get rid of the numbers in front of the logs. Well, there's a 1/3 here, so I'll put that as my power. So this is going to become natural log of x minus 1 squared, x minus 7 to the 1/3 power minus natural log of x plus 8 to the 3rd. Now, here we got log of something minus log of something. Subtraction becomes division. And this is the 1/3 power, which is the same as the cube root. So I'll go ahead and put that into cube root form. So we got x minus 1 squared, x minus 7, all over x plus 8 to the third power. And that's our answer. And let me save this. Okay. Now we're going to take a look at solving exponential equations, and then we'll look at solving log equations. So let's refresh our memory on exponential equations from college algebra. Our first step. Get the part with the variable and the exponent by itself. So get the part of the variable and the exponent by itself. Don't want any numbers in front of it, don't want any numbers after it. Step 2, take natural log of both sides. Take ln of both sides. Step 3, use properties of logs to get the variable out of the exponent. And step 4, solve for x. Now, exponential equations, log equations is something that students have had a lot of trouble with in college algebra. One semester I came up with a document that the student could follow, step by step, that if they walked through it, it told them exactly how to solve it. Any type they'd run across. Wonderful document. Best piece of work I ever did. 6 pages long. I gave my usual spiel that class, sent them away with it, and thought, this is it, man. I have found a key. I was ready to publish it, become famous, so forth. They came back with as many questions as ever. And I started thinking about it, and I talked to them, and it was one of the stupidest things I've ever done. Nobody reads 6 pages. That's insane. So I've shortened it quite a bit with these 4 steps you see here, but they don't solve 100% of the problems anymore. And I will look at a couple of the oddball cases this doesn't fit on, so that you'll get at least an example of that. It's shorter now. Doesn't work all the time, but students actually read it, so that's good. So let's look at our first problem here. Equals -8. And the instructions are solve for x or t, depending on what variable you have. Well, remember we saw this earlier. When you have this, your base is e, and when those match, the e's and the ln going to cancel away and just leave you the exponent. So we got x squared minus 6x equals -8. Doesn't really fit these steps. Now we want to get everything on one side, 0 on the other, because we got an x squared. So we got x squared minus 6x. And I'll take -8 over, it becomes a +8. Now I'm going to factor that using the PST method. Factors as x minus 2 times x minus 4. Well, 0 factor property, we get 0 one side, we factor the other side, we set each factor equal to 0. So I'll set x minus 2 equal to 0, and x minus 4 equals 0. And I get x equals 2, and I get x is equal to 4. And those are our answers. Let's look at this one. 200 e to the -x plus 3 equals 800. Well, this is the exponential equation. Exponential equation means you have a variable in the exponent. And Let's go through our steps. Get the part of the variable and the exponent by itself. Well, we can't have any numbers in front of it, can't have any numbers after it. So we want to get rid of that 200. So we'll divide both sides by 200. Like that. So we got e to the negative x plus 3. 800 divided by 200 is 4. Step 2, take ln of both sides. So take natural log of both sides. Step 3 says use properties of logs, get the variable out of the exponent. Remember, this is base e, so when that matches that, all the log and the e's cancel, and just leave your exponent. So you got negative x plus 3 equals natural log of 4. Now I'm solving for x. I'm going to take the negative x to the right side and natural log of 4 to the left. So we got 3 minus natural log of 4 is equal to x. And that's our answer. The next one is a log equation. I think I have some more exponential equations mixed down below, but this next one anyway is a log equation. And our first step, get everything with a log on one side, everything else on the other side. Step 2, use properties of logs to get a single log. So use properties of logs, get a single log. Step 3, use definition of log to rewrite in exponent form. Step 4, solve for x. And I know that's kind of vague, but at this point it could be a linear equation, could be a quadratic, could be a rational equation. And step 5, semi-check your answers. We don't need to fully check them, we just need to make sure we don't have log of 0 or log of a negative number. Yeah, let's look at our next problem. Number 15. We have 5 plus 2 natural log of x is equal to 9. And same instructions, solve for x, t. Well, step 1, get everything with a log on one side, everything else on the other side. So I'm going to take the 5 over to the right side. So we have 2 natural log of x is equal to 9 minus 5. So we got 2 natural log of x is equal to 4. Now step 2 says use properties of logs to get a single log. We just want log of something. Don't want any numbers in front of it, don't want to have 2 logs or anything like that. Now you could use properties of logs, but there's an easier way. Sometimes you can use simple algebra to get it by itself. You see how this has a 2 here? If I divide both sides by 2, that'll get rid of it. So then we've got natural log of x is equal to 2. Step 3, use definition log to rewrite in exponent form. We take our base, which is e in this case, to a power of the other side equals what follows our log. So again, we take e to a power of the other side equals what follows our log. Now, solve for x. This is already solved for x. Semi-check your answers. If we put the e squared back up here, it doesn't cause log of 0 or log of negative number. So that's our answer. This is another one where we can use some simple algebra to get the log by itself. I'm not sure why I worked 2 of these. I want to get the log by itself. That's get a single log, I should say. So I divide both sides by 5. And we get natural log of x is equal to 3. Again, take our base, which is e, to a power of the other side, equals what follows our log. And that doesn't give us log of 0, log of negative number, so we're fine. Okay, number 17. We have natural log of x plus natural log of x plus 4 is equal to 0. Well, I'll get everything with a log on one side, numbers on the other side. That's done. Use properties logs to get a single log. Well, log of something plus log of something. Addition becomes multiplication. So we've got x times x plus 4. Well, then we want to rewrite in exponent form. We're going to take our base, which is e, to a power of the other side. So we've got e to the 0 is equal to x times x plus 4. And now we want to solve for x. Well, e to the 0 is 1. X times x is x squared. X times 4 is 4x. Hopefully this one actually has an answer. I never thought about actually checking it when I made the numbers up. This is a quadratic, so we want to get everything over one side. So I'll take the 1 over. So we've got x squared plus 4x minus 1. This doesn't factor, so I have to use quadratic formula. A is 1, B is 4, and C is negative 1. A is the numbers before your x squared, B is the numbers before your x, and C is the number at the end. And we want to plug it into this formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. So that gives us negative 4 plus or minus square root b squared, so 4 squared minus 4 times a times c all over 2a. That gives us negative 4 plus or minus 16. Negative 4 times 1 is negative 4 times the negative 1 gives us a positive 4 over 2, which gives us negative 4 plus or minus square root of 20 over 2. And we can simplify that square root. 20 is 2 times 5 over 2. Now we got a pair. We're looking for a pair of something. Here's a pair of 2's. They're going to come out as a single 2. So we got negative 4 plus or minus 2 square root of 5 over 2. Now remember, if you can divide this number, and this number by the same number, do so, and they're all divisible by 2. So that gives me negative 2 plus or minus 1 square root of 5 over 1, which is negative 2 plus or minus square root of 5. Now, if I plugged in the negative 2 minus square root of 5, it wouldn't work in this. So our only answer is negative 2 plus square root of 5. Now, the reason why that is you cannot have log of a negative number. And negative 2 minus square root of 5, I don't know what it is, but it's negative. And I don't know what this is exactly, but it's positive. So I know it'll work in both those. Let me save this. Usually TV distracts me. I have it on. Poseidon Adventure's on, the original one. It was one of my favorite movies way back when. Good lesson. Never go on a boat. It'll flip upside down. I never have been on a cruise. Probably those cruise packages don't like it when these movies come on. Getting people thinking about a boat flipping upside down. Okay, let's look at this one. It says solve for x or t. This is an exponential equation. We have a variable up in the exponent. So our steps for exponential equations, if you remember, is get the part of the variable in the exponent by itself. Well, we don't want any numbers in front of it, don't want any numbers after it. So we're going to divide both sides by 50 to get rid of that 50. So divide that by 50, and divide this by 50. So that gives us 1.03 to the 5t power equals 16? Yeah, 16, I believe. Okay. Now we got the part of the variable and the exponent by itself, so we'll go ahead and take natural log of both sides. Now we want to use third step. You want to use properties of exponents to get the variable out of the exponent. One of our properties says if you have a power, you can put it out in front of your log. So put 5t out in front. And we've got 5t natural log of 1.03 equals natural log of 16. Now we're trying to get to t by itself. The 5 is a number, and the natural log of 1.03 is a number. So I got a number in front of it, I got a number after it. So we're going to divide both sides by those numbers. And we've got t is equal to natural log of 16 over 5 natural log of 1.03. Now you have to be careful when you plug this in. If you have more than a single number or a single variable on top and bottom of your fraction, you want to put parentheses around it. So when we plug this in, assuming you're going to plug in your parentheses, or plug in your calculator, you have to put parentheses around the bottom part. Now the top part's just a natural log of 16. That's considered like one number. And actually, let me show that. So we got natural log of 16. And I'll put a closing parentheses, divided by, and then beginning parentheses around the bottom. So 5 natural log of 1.03. You can put closing parentheses at the very end if you want, but it doesn't need them. And we get t is equal to 18.8, taking one decimal place. Not sure what they'll leave as their answer. Usually exact answers are better, but in business, 18.8 means a lot more than this right here. So let's look at our last problem. It says 8,000 invested in an account at interest rate R, compounded continuously. Find the time required for the amount to double and triple. Okay. So we got it's compounded continuously, so it's our PERT formula. So it looks like this. If you remember that from college algebra. Now A is your ending amount. Doesn't tell us ending amount. We'll come back to that. P is our principal, or beginning amount, how much you invest, which is 8,000. E and R is 0.025. And then we're wanting to find T, so that's just T. Now this is part A, which says double. Well, if I put 8,000 in and I want it to double, that means this is going to be 16,000. Now this is an exponential equation. You got a variable up in the exponent, so we want to get the part of the variable in the exponent by itself. So we'll divide both sides by 8,000. And we get e to the 0.025 t. 16,000 divided by 8,000 is 2, equals e to the 0.025 t. Now we're doubling our money. Notice how we came up with a 2 here. That will always be that way. Your principal and your A will always disappear, and you'll always just be left with 2 for doubling. Well, now we're going to take natural log of both sides. So we've got natural log of 2 is equal to natural log of e to the 0.025 t. Well, this natural log and this e cancels away, and you got 0.025 t. And then divide both sides by 0.025. So we've got natural log of 2 divided by 0.025, and that'll give us our t. Okay, so we got natural log of 2, closing parentheses, divided by 0.025, 27.7 years would be our answer for part A. Now for B, I think B is triple. Yeah, triple. So instead of a 2 being over here, we'll have a 3. And all the rest of it's the same. So then we'll take natural log of both sides again. And then we got natural log of 3. And natural log and e cancels away. And you got 0.025t. Then divide both sides by 0.025. And you got natural log of 3 divided by 0.025. Whatever that gives you. Natural log of 3 divided by 0.025 and 43.9 years would be how long that takes to triple. And I think that was the last problem. Yep, so let me save that. And I'll stop the recorders. There we go. Recorder. Stop. That's good because Poseidon Adventure was coming on to the good part, the end when they're being rescued and his wife dies, and well, I don't want to ruin the movie for you if you haven't seen it.